A gentle scrubbing motion ensures a good contact. In an oven, the strips are exposed to high temperatures to cure or harden the adhesive. In wire bonding, thin gold wire is used to electrically connect the die to the lead frame. The thread bonds to the pads on the die and to the lead fingers of the frame. In slow motion, we see the thread connect to the pad and then to the tip of an individual lead. These pins, or lead fingers of the frame, are now attached to the microscopic circuitry of the integrated circuit. To protect the circuitry and its fragile wire bond, the devices will now be encapsulated in hard plastic. This requires a two-sided mold. Between each operation, the bottom mold is brushed clean. The circular cavities will hold pellets of plastic molding material. When heated, the melted plastic will flow through the small channels to fill the rectangular cavities which will hold the devices. After several minutes, the encapsulation process is complete. The remaining plastic pellets and excess plastic are removed from the mold. The leads are now prepared for plating. Inside this machine, under high pressure, sand-like beads will blast away any remaining dust or specks from the molding compound and the leads. In ovens, the plastic molding is fully cured so it can withstand the plating process. In the plating process, the strips are loaded onto carriers and dipped in a series of chemical and water wash baths. In the plating baths, with anodes of tin and lead, the leads are plated with a layer of solder so that the chips can be easily attached to a printed circuit board. In this process, the individual devices are removed from the strips. The leads are cut from the frame on 4 sides and bent into their final configuration. The formed leads are then cut to their final length. The chips are punched out of their frames, and each one is now an individual package. The individual chips now undergo testing. They are loaded onto burn-in boards which will be placed in ovens. These boards consist of many electrical sockets. When connected, they allow electrical contact with each chip. In these boards, the chips will be stressed far beyond normal conditions. Weak chips are forced to fail prematurely before they are put into a customer's product. The loaded boards are slid into their electrical receptacles. In rows and rows of burn-in ovens, the chips are powered up and exposed to high temperatures for several hours. This stress encourages potential defects to occur faster. In another test, the chips are exposed to contrasting cold and hot temperatures before they are electrically tested. This large computer controls 2 testing handlers. Inside the handler, we see the chips move to the testing region. An electrical socket tests each lead to determine performance characteristics. Depending on the test results, the chips are sorted as those that meet specified requirements, those that meet lower requirements, and those that have failed. The chips that pass are marked with a logo. They are laser marked, visually inspected, and packaged for distribution. Soon, these chips will be placed on a printed circuit board.